Okay, in this video, which will be a short video, we're just going to introduce, well, really not introduce, but continue and extend our concept of the confidence interval. We've done it for just a regular mean score that was based on raw scores. We've done a confidence interval now on an independent t-test, and now we're going to get a confidence interval for the dependent t-test. Before I do that, I want to go back and make sure that we understood again where we get this. We know where we get this calculated t. This calculated t is coming from, our t-test formula, but the critical t is 2.306 again. I just want to make sure we understand, it's t at alpha 0.05. So if you go over here to this, and I've inserted the table in here, we're doing a two-tailed test. We have alpha at 0.05. So if you look here at alpha of two-tailed 0.05, that's here, and our degrees of freedom of 8 here, and you look at the intersection of these two lines, column and row, you get 2.306. So that's the cutoff region on that distribution. What would that look like again? So this is some kind of t distribution, and in order to essentially capture 95% of the population and whatever this distribution looks like, your cutoff scores are negative 2.306 and positive 2.306. I just want to again make sure that we understood where this value right here is coming from. Okay, moving on then to the confidence interval piece here. The 95% confidence interval for paired samples. That's kind of our title here. So how is this calculated? Calculated is 95% CI equals our D bar, and then to that you're going to add and subtract this cross product of this critical t. Well, what's your critical t? That's the t that you chose at alpha. Let's bring that back just for a sec. Alpha two-tailed at your new value or your degrees of freedom multiplied by the standard error of these mean difference scores. Okay, so when you kind of plug and chug this, then the 95% CI equals this D bar, by the way, 29.56, which is, that was our D bar, plus or minus the cross product of 2.30, let's get that right, let's do another back, 2.306 multiplied by the standard error of the mean differences, which was 2.68. Where did these values come from? The 2.306 was your critical t. It was again this value right here, and then your 2.68 is this standard error of the mean difference piece, which was right here. Okay, continuing just to kind of simplify this, we get 29.56 plus or minus 6.18. So that gives us an actual confidence interval of, when you subtract it, the lower bound part of the confidence interval is 23.38 and the upper bound is 35.74. I guess it's important to note here that there's still units attached to this, and the units are in pounds. And remember, we said that in a confidence interval, when we're testing the null, remember the null hypothesis here, because our table is covering it now, was that the mu, or the population mean of the difference scores, is equal to 0. So what we're saying is if 0 is a member of this confidence interval, then we're saying it's likely that the difference in the population is 0. And as you can see here, 0 is not between 23.38 and 35.74. We're saying that the actual difference in the population is going to vary from 23.38 to 35.74, and because 0 is not a possibility inside of this interval, we're rejecting the null. It's just a different, again, it's a different way of approaching it. Again, the classic way of doing it is calculated t beating critical t, but if I take a confidence interval approach, you can say, well, I expect the mean of the different scores in the population to be between 23.38 and 35.74, and because 0 is not a member of that confidence interval, I feel confident challenging the tenability of the null hypothesis and saying that the alternative is likely the case, that in fact our weight loss supplement was actually able to then decrease body mass, in this case body weight, in terms of pounds. So that is the interpretation of the confidence interval. Thanks for watching this video.